In this module, we're going to be talking about how you can use Amazon's Elastic MapReduce to run Hive and Pig jobs. In previous sections, we've been focusing on running custom Java code, custom Hadoop jobs. But in this case, we're talking about how you can execute Hive and Pig scripts using Amazon's Elastic MapReduce support. Now, this module assumes that you already know about either Hive or Pig. So what we're going to talk about is the specific things that you need to know in order to use Hive or Pig with Elastic MapReduce. Why would you actually want to use Elastic MapReduce when running your Hive jobs? There's a couple things. One is it simplifies the setup. So when you ask Amazon to create a Hadoop cluster for you in Elastic MapReduce, you can tell it to automatically set up Hive or Pig. So you don't have to do anything extra in order to run your Hive jobs. You already have a database running that you can use to store your Hive schemas. You have a very simple way of both running, monitoring, and then also terminating your Hive jobs because you've got the Amazon Management Console and also the command line tools that let you interact with Hive. There's some things that Amazon's done to extend and improve Hive. So for example, there's a JSON SERDI that lets you read and write data in JSON format. And there are a bunch of patches that they've applied to Hive to improve how it runs inside of an Elastic MapReduce cluster. For example, there's various things that you can do with Hive in EMR, like reading and writing tables to and from S3 that you couldn't do with a regular version of Hive. And there's a full list of them on the Amazon website at the link you see here. So how do you actually go about running a Hive job? Well, you create a Hive job flow. The sequence is very similar to running a regular Hadoop job in that the first thing you do is you've got to upload your Hive script. You've got to say where your data is coming from. So you do this process of configuring a Hive job flow. Then once it's all ready to go, you say run. Amazon takes care of setting up the cluster for you, executing your Hive script, and then terminating things when it's done. So what's the difference between using a Hive flow and a custom jar? I mean, both you can do, you can set up the job flows using the AWS Management Console or the command line tools. When you're running a custom jar, you've got code that you've uploaded as a Hadoop job jar into S3 versus with Hive job flows, you have typically a Hive script that you put somewhere in S3. The data in both cases often comes out of S3. Though it doesn't have to, and the results typically wind up again in S3, though if you look, for example, at the running a data warehouse using Hive tutorial that's available online, in that case I believe it's actually writing results into SimpleDB versus saving them in S3. So what's the first thing that you need to do when you're running a Hive job flow? Well, you need to set up a bucket in S3, and in here typically then you've got your Hive script, you've got where your data is coming from, you've got where you want your results to go to, and you've got where you want Amazon to save the logs from the job. And all of this can be done using the AWS console in terms of setting up the bucket in these directories and also uploading files. So we're going to go set up that bucket right now. So here I am. I have logged into the AWS Management Console, and I'm sitting here in the S3 Bucket Explorer. And at this point, I can create a new bucket. For example, let's call this bucket AWS Test KK. And once I've got this bucket, I can create some folders in here. So I know I want to have a folder called Scripts. I know I'm going to want to have a folder called Data. I need to have one called logs where my logs file will go to, and I'm going to create a folder called Hive results where my results are going to go to. Now at this point I have some things I need to upload in here. So for example, into scripts I am going to upload my HQL file, my Hive query language file, and that one is located right here. And this is pretty small, so it shouldn't take very long to upload. Then I'm going to go back here and I'm going to upload some data that I want to process. And this is going to take a little bit longer. Now, when you're doing your lab, you won't have to do this because this data is already uploaded and available for you. In this case, inside of data, I've got a sample of the Wikipedia data. And this is the XML files that were generated from a dump of Wikipedia that are also used for the Wikipedia Ngrams lab for writing custom Hadoop jobs. So it has a bunch of lines of text where each line has a single page in it. If we take a look at what that data actually looks like while this thing is uploading, you can see it looks like this. Right? So you have these lines of XML where you've got a page tag, and inside of it's a title, and here's the title for the article. And eventually you'll get things like a revision timestamp and a contributor's username. And we're going to take advantage of those in the actual lab, and we're running that same lab code here. So once this is uploaded, now I'm actually ready to go and start running the, start defining the Hive job flow. When you set up a job flow, you have a whole bunch of settings that you can specify using the AWS Management Console or the command line interface. So for example, when you're setting this up, you need to give it a name, you need to say how big your cluster is, where you want it to put the log files, etc. So this process is pretty straightforward. I'm going to come back over here to the AWS Management Console. I'll click on the Elastic MapReduce tab. And here I say I'm going to want to create a new job flow. So I'm going to give it a name. In this case, it's, Wikipedia contributors. And the job type here is going to be a Hive program. Now I have to tell it where this actual script is located in S3. So it's AWS test kk scripts hive lab.hql. And then you can set up input and output locations. And these, it's a little bit confusing because really what's happening here is whatever you put in here for the input location and the output location, Hive just defines these as variables that you can use in your scripts. They don't mean anything else other than in your script you can reference a variable called input, and it will have whatever you enter here, and you can also reference a variable called output, all uppercase, and it has whatever you put in here. So in this case, the input, I want to say, comes from S3, and it's AWS test kk data. That's the directory that has the files in it. And the output location, I'm saying I want to go into the AWS test kk bucket, and here I wanted to put it in Hive results. Now notice here, and we'll talk about this in a little bit, I have an option of starting an interactive Hive session where I'm not actually executing a pre-created Hive script. I'm just setting up to be able to work with a Hive interpreter to define what goes into a script. At this point, I can set up the size of my cluster. I want it to be a very small cluster, so I'm only going to have a single slave, which is an M1 small, and my master is also an M1 small. No spot instances and no task instances. At this point, just in case I wanted to, I'm going to set up an EC2 key pair with a previously created key, AWS test, which would let me log into the master if I wanted to. And right here, I have to specify where the logs are going to get written to. I don't care about additional debugging, and I don't want the cluster to stay alive when I'm done. I don't need any special bootstrap actions for adjusting the configuration of my cluster. Now I can take a look at all these settings here and make sure they're right. And once I'm pretty sure they're right, I'm going to create the job flow. And what's going to happen here, if we view just the running ones, this one is going to start up, and then it'll switch from starting to running, and it'll start processing the data. And then when it's finished running that script, its status will change to completed. Now at this point, I can monitor my job. We were looking there at the AWS Management Console to see the state of the job, whether it was starting or running or shutting down, and how long it had taken, and the normalized instance hours, which gives me a sense of the cost. I can terminate that job, and I'm going to show you something that we covered in another module, which is, how do I go about actually watching the real Hadoop jobs run, which is sometimes a useful thing to do in terms of progress. So we're back here, we're still starting up. And if I click on this, then the key thing for me in the description tab down here is whether I have a master public DNS name. Once this gets set up, then I have the ability to actually set up a proxy server so I can look at the Hadoop GUI and get a better sense of where my job is. Until it has a master DNS name, there's not a whole lot I can do other than sort of watch it here. And the status here is still, it's starting up all the instances, which is why I don't yet have that master DNS name that I can use. Now at this point, our job is finally actually running. If we select the job flow here and we look down, we'll see that it's got this master public DNS name that we need. If I copy this name and then I switch over to a terminal window, and in here I say SSH, and I'm going to use the private key pair from the key pair that the private key portion of the key pair that I previously generated using the AWS Management Console. And then I do a little special magic to set this thing up to be a proxy, and it's proxying through port 6666. And I always need to use the Hadoop server here and that same master public DNS name. And it'll ask me, do I want to add this to my list of known hosts? I say yes, and at this point I'm proxying. What that means is, back over here in the browser, because I've configured my browser with Foxy Proxy to know about proxying through port 6666, I actually have access to the Hadoop console. And at this point right here, it's not yet running any jobs because it's still figuring out which job or jobs it needs to run. So the Hive is busy doing that right now. If I switch back over here, you can see it's only been running for 2 minutes. But pretty soon now it'll start actually running jobs. So it started running my first job down here. I'm again using the Hadoop GUI to take a look at what's really going on under the hood here when Hive has turned my query into 3 MapReduce jobs. This first job right here has just started, so it's busy reading from S3, so you can see it's read about 4 megs worth of S3 data. If I refresh, you can see that it read all of the S3 data, all 12 megabytes of it. The map is complete. The reduce hasn't quite started running yet. You can see that I have roughly 10,000 lines of input data. That's essentially that size of that Wikipedia sample.xml file. If I refresh again, you can see the reduce is completed. If I go back over to main view, first job is finished, and it's setting up to run the second job. If you go back over to the AWS Management Console, you can see that we're about 4 minutes in here. Total time would be about, I think, 7 minutes. At this point, now we're done running all 3 of the jobs, the Hadoop jobs that Hive had created in order to fulfill the request I'd made, the query I'd given it in the hivelab.hql file. If we go back over to the AWS Management Console, it says that the status is still running. The job itself is finished, but what it's doing is it's copying logs over into S3, and then you just saw it switch the state to shutting down, so now it's terminating the cluster. Similar to when you're running regular Java code, regular Hadoop jobs, at the end of a Hive job flow, the cluster goes away unless you say that you want to keep it running. So that means anything that you've created, any tables you've created in Hive that by default have gone into HDFS get tossed. So that means you need to wind up putting the end results somewhere in S3 or some other place that's going to persist. The other thing is that the Hadoop log files have automatically been copied for me by Elastic MapReduce into S3, into that location that I specified when I was defining the Hive job flow. So we can go take a look at that now. So over here, if I go over to S3, and I see my list of buckets down the left side, the one we've been using is AWS Test KK. In here, I've got my Hive results, and there's a file here with 6 zeros in its name. This is the actual table that I created as a result of my Hive query. And if I open this up, it's going to display it. Since it's an unknown format, I'll open it up using bbEdit, and what it has here is a list of the top contributors to Wikipedia, at least the most recent edits for files, and their counts. And many of these are bots, which means they're automatically doing things, but you can see there are some actual users who have made a lot of changes, and some of these users have very interesting names. The other thing I can look at is the logs for the jobs that I did. So if I look here in the logs directory, inside of here, each one of these is from a different run that I did, a different job flow. The job flow we just ran had a job ID of J-V8I, blah, blah, blah. If I open this up, most interesting is inside of this steps directory. If I look in the steps directory, step 1 was the step of setting up Hive. Step 2 is my actual sort of flow that ran. In here, Hive actually puts a lot of its information into standard error. So if I open up standard error and I take a look at this, you'll see here that it's a bunch of output from Hive. And remember how when we were looking at the job using the Hadoop GUI, we see there actually were 3 jobs. So here's the first job, here's the second job, and there's the third job. Now the kind of job we ran there is one where we already have a fully debugged Hive script, that hivelab.hql file. And that's great for when you've got something that's in production, right? So you're doing batch processing using Hive. But the act of developing Hive scripts, as anybody who actually has done it knows, has a lot of trial and error as you're trying to get the query right and you're trying to get all your parameters set up properly. And the issue is if you're trying to use the approach of taking Hive job flows and giving it a script and running it, is that when your script has an error, your cluster finally fires up after a couple minutes, and then boom, immediately has a problem, and it fails, and you've paid for the time that your cluster has spent in 1-hour increments. So you pay that, it's called the 10-second penalty. You pay for a full hour no matter what. So in that case, the solution is you start up an interactive session, and then you fire up the Hive interpreter via the command line tool, and this then lets you try out scripts interactively. So what you need to do is you start up your EMR cluster, your Elastic MapReduce Hive cluster, in a sort of stay alive mode, and you don't actually run a script. After it's done that, then you SSH into the master, which means that when you set this job flow up, you must specify a key pair so that you can use that private key to SSH into the master. And then when you're in there, you start running the Hive interpreter. And then when you're done, you have to remember, of course, to terminate this job flow. So we're going to go give that a try now. So I'm going to switch back over to the Elastic MapReduce tab. And I'm going to create a new job flow. In this case, I'm going to call it Hive development. And I still set the type to be a Hive program. But in the very next screen here, instead of executing a Hive script, I say I want to run an interactive Hive session. Now I still get to specify the size of my cluster, so I'm going to make it really small. And of course, I better set up an EC2 key pair so I can actually log into the master. Here I don't need any additional debugging. I don't really care where the logs go. I don't need any special bootstrap actions. I can check my things here, and I can create that job flow. And it'll take a couple minutes for it to set up the cluster and configure Hive. And at that point then, once again I have a master public DNS name down here, then I can use that along with my private key to log into the master and start running the Hive interpreter. And you'll see that the state changed to running, even though I didn't actually give it a script to run. The issue is it's running the first step, which is the step that is configuring Hive. Once it's finished that first step, then the state will change to waiting. And at that point, it's ready for me to start interacting with the Hive interpreter. We're finally ready. State has changed to waiting. Down here you can see that I have that master public DNS name. So I'm going to copy that. And now I'm going to switch over to the terminal. And here, same as before, I'm going to SSH in using the private key that I previously downloaded when I defined a public-private key pair and using the AWS Management Console. And then I log in as the Hadoop user to that same server. At this point, you can see I'm logged in, and now I can start running Hive. So it's a regular Hive interpreter. I can do things like, say, show me the tables that I've currently got defined. And you see that I've got no tables. From here, I can do things like I can source scripts. I can do all the usual Hive commands. For example, I could create a table. If I could type called, I don't know, test, and it's got a field name of type string and age of type int. Great, I've defined a table, so now if I do show tables, it shows that I've got a table called test. I could insert data into that table. I can start executing commands to define new tables based on the results of queries against that table. I can source, and then here, for example, I could put in a path into S3 of a script, and what it would do then, it would essentially execute that Hive script for me. And when I'm done, I can say exit, and I'm back now at the command line prompt on the master server that I logged into. So I need to exit out of here to really get back all the way out. And then once I'm done using Hive, I of course want to terminate this cluster. So if I select it, then I can click up here, terminate. It'll say, do I really want to terminate? I say yes, and the state changes to shutting down. All this stuff we've been talking about pretty much has had to do with Hive. Pig is very similar. When you create your job flow, you have the option of saying this is Pig instead of Hive. You have an interactive mode similar to Hive where you can work on developing your Pig scripts. Just some obvious differences, like if you're executing a script file, then it's going to be Pig Latin in there, not HiveQL. And there is an example of parsing log files using Pig for those of you who want to try out Pig and Elastic MapReduce, and the URL to it is there at the bottom of the slide.